Okay, here's a packet, and here's what's going to be in your next test. Okay, next week sometime. Determine whether each function represents growth or decay. Okay, so here's a way to do that. You'd want to set up a table and just pick numbers for x. Go from 0 to 1 to 2. You could stop there. So we have a 5 right here. Remember, it's not 3 times x, it's 3 to the x power. So I'm going to hit 5 times parentheses 3, and I'm going to raise it to the 0 power. Now this is going to be 5 when I hit equals, because anything to the 0 power is 1. Okay, so it'd be 5 times 1, which is 5. Okay, then if I take it to the first power, I get 15. Makes sense, so that's 3 times 5 is 15. Now if I raise it to the second power, that's going to be 9. 3 times itself is 9, and then times 5 is 45. So that's an obvious growth, okay? And you're going to get growth when you take the first number times a number that's bigger than 1 whole, okay? Okay, number 2, 2 times 0.75 to the x power. So 0, 1, and 2. So we have 2 times 0.75 raised to the power of 0. So that's 1 times 2 is 2. And then if I raise it to the first power, I get 1.5. That's going down. Now if I raise it to the second power, then I get a 1.125. Okay, this is a decay. It's going down because I'm taking a number, a 2, but I'm multiplying by a number that's less than 1 whole, so then it's going to go down. Okay, next problem. Okay, so I'm going to take 3/4 times, and now I'm going to put my 3 over 2 in parentheses. Remember the fraction key is the ABC right there. Raised to the power of 0. Okay, so I got 3/4. Now I click up, and I take it to the first power, so that's going to be 1 1/8. Then I click up, and I'm going to take it to the second power, so that's 1 11/16. Now, that's growing, so that's growth. The reason why is because I had 3/4 to start with, and then 3 over 2 is bigger than 1, because if I divide 3 by 2, that's 1.5, that's bigger than 1. Okay, number 4. (0.2) times parentheses 1/5. Remember that to get the 1/5, you go ABC. And I raise that to the 0 power, and that's 0.2. Then I'm going to raise it to the first power, 0.04. And then we're going to raise it to the second power, 0.008. Okay, so that's a decay, because it just keeps getting very small, so I have a decay function right there. Okay, number 5, I skipped 4. Okay, don't worry about that one. Graph the equation, identify the domain and range. Now, if you have an exponential function, because it's 3 to the x power, you're just going to put in 2, 1, 0, -1, -2. Now, all you're going to worry about to begin with, and you also are going to have that line known as the asymptote, okay? And the asymptote always starts with y equals 0, okay? So now I just go 3 to the second power. It's going to be 9. Then I raise 3 to the power of 1. That's going to be 3. Then this is going to be 1, because anything to the 0 power is 1. And then when I start doing it to negative powers, okay, it's going to be decimal, okay, because that's what a negative power does. It just takes what you get with a positive first power and just makes it a fraction and divides. So 0.33, just go 2 places out. And a negative 2 would be 0.11. Now there's the matter of this minus 2 right here, okay? I don't have to do anything to the x's. The minus 2 means I need to subtract 2 from all of my y answers and also subtract 2 from the asymptote. So 9 minus 2 is 7, 3 minus 2 is 1, 1 minus 2 is negative 1. 0.33 minus 2 is going to be negative 1.67. 0.11 minus 2 is negative 1.89. And with the asymptote, 0 minus 2 is negative 2. So it's going to be impossible for us to ever get below negative 2 in this. Okay, so on my y-axis, I go down to where negative 2 would be at, and I make a horizontal line. Okay, all points are going to be above that line. So 2, 7, 2, 3, 4, 5, 6, 7, 1, 1, 0, negative 1, I stay at 0, go down 1. Now, you don't have to graph the decimals, because all that happens is you get further away from the asymptote here. Here you get closer into it till you're practically going parallel to it. That's what an exponential graph is going to look like. Now the domain's x, the range is y. Now the domain's easy. If you have arrows both ways, which you do, because you can keep putting numbers in for x this way or this way, then the domain is all. Now with the range, we use that negative 2, and all points are above that line, so it's be greater than. But not equal to, because it never actually touches the actual asymptote. It just goes closer and closer to it. Okay, I know you're not a fan of graphing, but that's the only one you have to know. Okay, now this one says write each equation in logarithm form. This is kind of something a short little procedure you have to memorize. Write the word log over here, and what you're going to do is circle your power. You bring that over. Now the base of the fifth power 2 is what I put on the bottom right. And then I put 32 after the log base 2, and that's all you do. You're just converting it into another notation. Okay, so you need to write it in log form. So negative 3 goes here, because a log is always equal to the power that you see. The base is 5, and then you can put 1 over 125. Okay. That's the answer, that sentence right there. Okay, evaluate the logarithm. You're trying to figure out what the logarithm is equal to. These are going to be kind of easy, okay? This one might throw you for a loop, but it's not a hard one. So I multiply 2's till I get to 8. That's 4. 2 times 2 times 2 is 8. How many factors of 2 do I need? I need 3, so I put 3, and that's the answer. Okay, I just repeat this, and it's pretty repetitive. 16, and that equals 64, so that's 3 right there. Okay, now I'm going to multiply 12s. I'm definitely going to need my calculator here. So 12 times 12 is 144. Then that's too small, so I times 12 again. There we have it, 1,728. So the answer is 3. No, the answer is not always 3. I just wrote. I was kind of stupid on it about that. Okay, now if you have a 1 over the top of what the product you're trying to multiply by, you put a negative, and then you can just do 81. You don't have to worry about the 1 as long as you make it negative. So 1, that's 9. That would be 27. And that's 81. So that would be 4, but it would be negative 4 because the 81's been reciprocated, 1 over 81. Okay, write the expression as a single logarithm. Okay, what you do, you got log base 3. You want to write that one time, one single time. After the first, you've got x. And after the second, you've got y. So minus means divide when you're doing logarithms. So I divided by y. Now I'm forgetting about the 5 and the 3. Now the 5 and the 3, the 5 goes to the x as a power, and so the 3 with the y, and that's it. Okay, now you're expanding the logarithm. Okay, now you have 3 factors, a 6, an x, and a y. So 3 factors means I need 3 log base 5s written out. Okay, so we're going to have 6. X to the second, then I'm going to scribble out the 2 and put it in front like it is up here. Y to the 4th, scribble out the 4, put it right like it is right there. Now multiplication, when I extend it and make it expand the logarithm, then the multiplication goes with addition. Okay. Had that had said addition, I would have wrote dot y to the 3rd instead of divided by. Okay, that's how that works. Dots mean they're addition, okay? Now you got some equations to solve. Solving for x. Now if x is in a power, we have to find out what that little exponent up there equals, okay? So we have to find out what the whole power equals. So I got to go negative 2x plus 2 equals, and there's 2 ways I can do it. The first way is to figure out how many 3's, 3 to the what power is 81. So I want to get it to 81. So that's 9, 27, and that's 81. So that's 4. But that's not the answer. I got to translate it over here and then just solve the easy equation. 4 minus 2 is 2. Divide by negative 2. X equals negative 1. Okay, then in the next problem we're solving for x. So now we got to find out what the power equals first. So 2x equals. I'll put a little equals there. And now you got to figure out how many 6's it takes to multiply to 10. That's 36, so I'm already over 10. So if I cross the limit of 10, then I go to my log over log, okay? So 6 on bottom, 10 on top, okay? Log 10 divided by log 6, 1.29, and then I just divide by 2. 0.65. Okay, now number 17, we need to get rid of the log, okay? And also, I forgot something. I want to put a parentheses there, okay? So, because you want it to get it to look like one of these equations here. Now, what do you have in the parentheses? You have an x, okay? You put that by itself. Now, remember, the log is equal to an exponent, so I put a little 5 here, and then the 5 is going to have a base of 10. Well, if x equals 10 to the 5th, I just go 10 times 10 times 10 times 10 times 10. 100,000. Okay, number 18, solve the equation. I gave you a hint. You're going to have to use ln, but first you look outside the e, and if you have a number, you need to unmultiply it. So you're going to divide by 4. So e to the 2x power is 10. Now I had those parentheses, keep them in there. And now I can go to my ln, because if you remember, the ln and the e cancel, and now I just have 2x. And over here I ln my 10. I just hit ln 10. 2.30. And I divide by 2, and that's going to be 1.15. Okay, number 19. Hint E. Well, you can go to your e right away, okay? E, that goes away. And I have x plus 2, but on the other side I have e to the 8th power. So to get to e, I go second ln 8. Big number, 2,981. Just round it to a whole number, then I subtract 2. That's going to be 2,979. Okay, then there's going to be 2 story problems. You have $500 in a savings account that earns 2% interest per year. How much will the account be worth in 10 years? Set up your box, and you got dollars and years. You don't have to use that big long formula. I'm not going to give you any like that. So X is years, Y is dollars. So per, we're going to go dollars per year. But there's no dollars per year. It's a percent per year. So interest is adding, so put plus 2%. And when it goes by a percent, you don't make your line. If it was $2 per year, it would be a linear equation. But this is an exponent equation. And we want to set those up using a times b to the x power equals y. Now, you're going to go to the side and list out what all your stuff is going to be. Now, the a and the y are the same label, okay? Y is money. These are both money signs, okay? Now, the a is where your money began, which is 500. The y is where your money ended, which we don't know. So I'm going to put question mark, okay? Means we're going to leave that just y. Okay. The b is found. It's called your growth factor. You take 100% plus 2%, and that's 102%, but that would be 1.02. Okay. And then x is your years, which is 10. So now I just put these into the formula. So a is 500. The b is the 1.02. The x is to the power of 10 equals y. So to solve for y, I just need to plug that into my calculator. Okay, I got $609. Okay, then the last one, number 21. You deposit $800 in a savings account that earns 2% interest per year. How long will it take the account to earn $1,000? Years is X, dollars is Y. So dollars per year, again, it's not $2 per year, it's 2% interest, so that's plus 2%. So that means I'm going to set up the same thing I did last time. A times b to the x power equals y. Now a and y, we want to talk about those first because those are the same label. Y is dollars and a is going to be $1 first. So a is where your money began, which is 800. And the y is where the money ended, which we know in this problem is 1,000. Okay, now the b you need to find by taking 100% plus your 2%. The b is your percent. You got to add or subtract it to 100. In this case, add. Move the decimal twice, and that's 1.02. Okay, x we don't have, okay, because that's the answer. So question mark, so we just leave the x the way it is. So a is 800. B 1.02 to the x power, and then y is 1,000. Okay, now we have to solve for x. Okay, so x is an exponent, parenthesize its base. And when we have to solve for the exponent, we need to first get rid of this 800, okay, by dividing, not by minusing, okay. 1.25. Then I go to my log over log down here. That's why I made a little box here. So the exponent x, there won't be a 4 you have to worry about. Okay, and then log, log. Okay, so 1.02 is on bottom, 1.25 is on top. X equals 11.2, but down in the answer, just take that up to 12. Even though that doesn't round to 12, it would take one more year from the 11. Okay, that's all I have on that.